Okay, hello. This is my solution for the 8 puzzle project for artificial intelligence. So I'll run some codes. This is BFS for easy, UCS for easy, and you can see the output shows the step, the increasing costs, increasing basically the depth here, the total cost here. I assume if easy and medium work. Well, I've tested them all, but I assume you can assume. I don't want to show you everything. Take too long. So that's, and then DFS of course goes insane. So this is my code. I have my goal state right here. I saved it as just a one-dimensional tuple. I created a node class. It saves the state, parent, action, all the good stuff. I had to implement an equals and less than function in the node class for the Python heap queue to work correctly while sorting nodes. And then I have my move functions, which each of my sorts call to move the data around. So it checks if the move is valid. It makes a list because tuples are immutable. And then it does all that. Switches them around right here. Puts it back into a tuple. And then right here, it checks if it's in the queue, and it updates it if it is, and then if it's not, it returns a new node right here. And then the right, up, and down functions are all the same, except they move it in different directions, of course. Move piece here just calls, it's a helper function. Got my heuristic functions, pretty basic, just checking if they're out of place here. But I just did modulus and integer division by 3 to get the Manhattan distance. Print functions, blah blah blah. So I got my actual search functions here. And so I just have it, while this current state isn't the goal, then it adds the puzzle to the marked dictionary, which is the dictionary of marked things. And then it calls move piece, which returns a list of nodes from the move piece function up that I explained earlier. And then for each of those nodes, if it is a node and the function can return none, and it's not in marked, so it hasn't already been visited, so that's the second check. If it's been visited, then it puts it in the queue, and then gets it from the queue here. And then DFS is the same deal, except it uses a stack, which in Python is just a list, and then use append to put on and pop to take off. Uniform cost is the same thing, except I used the heap queue that I imported up top. So a heap queue is just a queue that's sorted from when you pop, the smallest index gets popped. So, because it's a min heap. So of course uniform cost and heap push, this is the heap. This is what it's sorted by, so the path cost for uniform cost, and then the thing is pushing, and then it pops it right here. Best first uses the heap push again, but of course it's sorted by H1 instead of the path cost. And then A1, same thing again, except it's H1 plus the path cost. And A2, which is H2 plus the path cost. And I believe that covers about everything that one may need to know.